Greetings, science family. Today we're going to be looking into how we measure gases. And to be able to do that, we're going to have to look at a few different ideas. So let's get right to it. First of all, when we want to describe a gas, we sometimes will need to say about how much of the gas there is. Now, not necessarily how much space it takes up, but actually how much there is. So we would describe that by moles. And that's something that we're familiar with already in the class, but we can describe gas by moles. Just so you know, whenever we use an equation where moles or the amount of gas would be part of that equation, we use the letter N to note it. Another way that we describe a gas is by its volume, how much space it actually takes up. So for the volume of a gas, it's just going to be whatever the container is, meaning, if it's a large room, the volume of the gas will be the room's volume itself. If it's in a jar, whatever the volume of the jar is, that's going to be the volume of that gas. So some units we can use, liters, cubic centimeters, milliliters, decimeters cubed or cubic decimeters. But the common ones are really liters, cubic centimeters, or milliliters. And as you can see, these are all equal to each other. So that means when we're converting back and forth, you can use these as a conversion factor in order to convert back and forth from one to the other. All right, but we definitely can describe gases by volume. We can also describe it, important, by temperature. Temperature, we use a capital T whenever we're using something that has an equation. You guys don't know, this is Sean Paul. He had a famous song called Temperature. I thought it'd be funny, but it's probably not to you, but it makes me laugh a little bit. I'm actually smirking right now. All right, when we measure temperature, the most common form of temperature measurement, the unit Celsius, is what we use in science. However, when we're actually doing calculations with gases, we want to use what's called the Kelvin scale with a capital K. But it's easy to convert from Celsius to Kelvin. All you have to do is take that Celsius degrees and add 273 to it, and that will give you the same amount of temperature, but in Kelvin. Remember that the higher the temperature, the more energy a gas has. So actually measuring the temperature is something super valuable when we're talking about gases. The last thing is going to be pressure, or capital P, whenever we use that in some type of math equation. Now, pressure is something that we all understand, right? It's that the gas is pushing because of the random bouncing and motion of the gas as it pushes on the walls of its container and forces outward. Think of like air in a balloon pushing out on the balloon rubber to hold it open, right? That creates a pressure. Or inside a tire in an automobile, right? That gas is pushing against the walls, which is creating that force, that pressure. But measuring pressure is something we don't do often in our everyday lives. So for any of you that are into cars, you're probably familiar with PSI, or pounds per square inch. That's something that we use to measure tire pressure in our actual vehicles. But there are a bunch of other units for pressure that we might run into. So this is something you're going to need to get familiar with to get comfortable with. Pressure can be measured in something called atmospheres, pascals, kilopascals, and also millimeters of mercury. I'll give you guys a conversion sheet to show you how these are all related to each other, but this is something you should study up and get used to, these different units for pressure. Because if you just see kPa as an answer, like 50 kPa, to you right now, that might be something that you say, I don't know what that is. But then now that you can say, oh, kPa is kilopascals, that's a unit for pressure. All right, so we're talking about pressure here. This must be my pressure of my gas. So that's just something you're gonna need to get used to, even though we haven't used it a lot. So that's why we're learning it. Now that we've talked about how to describe gases, let's talk about how gases affect us. One of the biggest things in ways that gas affects us is atmospheric pressure. And that's actually the force being pushed down on us on planet Earth because of the air or the gases above us. Now, here's the reason we have atmospheric pressure. We know a physical property of gas is that it has mass, right? So all these little gas molecules and particles above us, all right, billions and billions of them, are constantly being pushed down on us because of gravity. As gravity technically pulls down on those gases above us, it actually pushes a force down on us. So we have this force or this pressure being pushed on us. And it's not just down, but on all angles. So if that's you, this little stick person, right? The gases surround you constantly and are pushing against you. What is that pushing? It's really all those little tiny molecules and compounds, right, of gases that are constantly colliding and bumping into you. All of that gets pulled down by gravity and forces on you, and that's what makes atmospheric pressure. So, atmospheric pressure, think of it this way. If this is you standing in the United States, think about the miles and miles of gas above you. And because of gravity, those miles and miles of gas above you are pushing down on top of you. If you are at sea level, we would call all that pressure being pushed down on you 1 atmosphere of pressure. All right, so it really is this force being pushed down on you. In class, I'll try to bring in an atmosphere bar, and you can actually feel how heavy the air pressure is on you right now, even though we don't feel it. Remember, we were born into this environment, this atmosphere. So your muscles, your bones, your body are used to it. It's kind of like if a fish is born in the water, it really doesn't know that the water is more dense than air and it's difficult to move through. To a fish, it's normal, right? So that's what's normal to you, is the atmosphere you were born into. So the atmospheric pressure can actually change. One of the ways it can change is by your elevation or altitude, how high above sea level or down low you are. Think about that. If this is the edge of planet Earth, and then we take a column of air, and we know that the pressure pushes down as you get lower and lower, think about that. The higher up in altitude you are, the lower pressure. Why? Because there's less air above you the higher up you are. So that means lower pressure. However, if you go to a lower altitude, you get more air pressure. And that makes sense because if you're down here, ground level, think of all the gas above you. There's even more gas above you compared to that higher altitude. And that creates more of a force or pressure on you as well. So the higher up you go, the less atmospheric pressure there is because there's less gas above you. We also know the higher up you go, especially like in the mountains, right? The air is thinner. There's less gas above you and there's slightly less oxygen, so you can get winded even quicker. For atmospheric pressure, there are changes in the pressure due to weather. In fact, if you think about it, when low pressure system comes in, it means that there's going to be rain or storms coming in, usually precipitation. And let's think about that. Why would rain coming in lower the pressure? Well, if you think about the mass of H2O, that's 1 hydrogen and 2 oxygen, that's about 18.02 grams per mole when you add that up. If you take just plain old oxygen, O2, right, that's already 32 grams per mole. So when you come in with rainy precipitation into the atmosphere, you have more lighter material above you because of that moisture in the air, and that lighter material above you lowers the pressure. So that's why a rainy or stormy weather comes in as lower pressure system comes forward. Now, if it's a high pressure day, comparatively speaking, you usually have sunny or fair weather. There's less moisture in the air and it's going to be like a normal day. So a high pressure system tends to be our nicer weather, right? Well, depending if you like rain or not, I guess it's a form of opinion. But again, that's cool, right? The atmospheric pressure, measuring it and the changes helps meteorologists determine the weather and what's coming. In fact, if you ever watch the Weather Channel or some type of weather broadcast, they often talk about the pressure systems and how that's going to affect the weather. Another thing that atmospheric pressure affects is cooking. Believe it or not, when you have a liquid, we like to heat up water to boil it for cooking a lot because we give the water energy to get hotter and hotter, and eventually the water has enough energy to escape as a vapor or a gas. So that's why we actually heat up water to boil it. It's to give it energy to boil away, and that's as hot as we can get water. Why? Because as soon as it hits about 100 degrees Celsius, it boils away and the water can't get any hotter. However, if you're up in a low pressure system, it actually takes a little less energy to boil off that water. So that means normally water boils at about 100 degrees Celsius, but at a higher elevation when there's lower pressure, maybe the water will boil at 95 degrees Celsius. Well, what does that mean? That means that the water's boiling at 95, you at a higher altitude are cooking food at a lower temperature. What does that mean? It means it slows the cooking down, which means it's going to take longer to cook things. So at higher altitudes, and you may have seen this on the back of cake mix boxes, it says to bake a cake a little bit longer if you're at higher altitude. And why? Because it's easier to boil water. That means that the objects cooking can't always get as hot as they would be at a higher pressure system at lower elevation. So you have to cook it a little bit longer because you can't get the object hot enough to cook faster. It's pretty interesting, isn't it? Something we don't think about, but the pressure dramatically affects us. You may, as a sports person, be interested in, like Denver, Colorado, the Mile High Stadium, and that the fact that the elevation is so high, the air is slightly thinner. Not only can athletes get winded more, but the air being thinner means the football can travel a little bit faster when you throw it. Or a baseball getting crushed into the outfield might be more likely to get a home run because the air is thinner and there's lower pressure. So again, this idea of pressure really can affect our everyday lives, more so than we probably thought. And last but not least, how do we actually measure air pressure? This is an example of a very old school, one of the first ways we measured pressure. What it is a dish of mercury. Crazy, right? A liquid metal. And there's a tube sticking out of it that's actually vacuumed out, so there's no air. What happens then is atmospheric pressure pushes on the mercury, which pushes it up into the tube. Well, what happens when the air pressure changes? Well, if there's less pressure, that mercury will be lower in the tube. If you get an increase in pressure, so let me do a bigger arrow, a bigger increase in pressure, that tube of mercury will get higher. So literally what old scientists used to do was just measure the height of mercury. In fact, on our pressure slide earlier, you saw a standard amount of pressure called 760 millimeters of mercury. You might have been thinking, wait, why is a length of mercury a pressure? Well, that comes from a barometer, the idea that we used to just measure the height of the mercury, and that would tell us if pressure was going higher or lower. In the end, though, a barometer now is something much more digital. It has a little metal leaf on it, a little thin piece of metal, and that pressure makes the metal bend, and then we get an electrical readout. But it's pretty cool to think that someone invented this idea of measuring atmospheric pressure with this barometer back in the day. Really cool. The reason, by the way, they used mercury is because it's a heavier liquid. If you used water, the water would go up and down way too much. You'd need like a super tall tube. So by having a heavier weighted liquid like mercury, it didn't change the height as much. So you could have an actual instrument that you didn't have to get on a ladder to read depending on the day. It was all right there in front of you. So, okay, fam, we talked about basically gases and how to measure them. In order to measure them, we need to know what describes them. So we talked about moles, volume, temperature, and pressure. All that is going to play an important part in understanding what gases do and how they act. So thanks for listening, Science Fam. Hope you took some good notes, and now let's get ready to apply it.